Okay, we're in section 15 of notes. Again, it'll be a short lecture, basically notational in nature. Certainly, we know how to take a derivative. What we're going to do now is take higher order derivatives. So for example, if we take a first derivative, that's what we've been doing, we could probably continue to do that by taking more derivatives. So if we got a derivative, then we take another derivative, then another derivative, then another derivative. This goes on forever, all right? So we're going to go through the notation. I will go to the board and we'll talk about this notation and why some notation is easier than others. But the bottom line, you should be familiar with what we're writing down after it's presented to you. After we present it, though, we need to do examples. Where the example is going to be derivatives. Have you been doing this for a while now? Yes. Are they going to get more difficult? No, but you may find it tedious, and we'll go through that when we get to examples. But first, let's talk about notation, and I am going to switch to the whiteboard. All right, you see my whiteboard now, and we'll talk about this page over here, and certainly talking through it is understanding what they're asking us to do. So over here, the first derivative is often indicated using prime notation, and I'm sure you remember that when I wrote this over here, the prime notation, I would write down that the derivative of the function f of x with respect to x was just equal to f prime. We did that. I might have also said that f of x was really just y. So what does this mean? The derivative of y with respect to x. All right. So dy dx. All right. I'm going to say that's not bad notation, by the way. The prime notation is nice, easy to read. That Leibniz notation, dy dx, is easy to read as well. The dy dx is actually better information because it's telling me what they're differentiating. All right. Now, the f prime, it can be very confusing sometimes, but the bottom line is it is used. Now, if you wanted a second derivative, I want to point out what that means is if you can do it once, you probably could do it twice. Right? So what am I saying over here? If you could find f prime, there's a good chance you could do the derivative of f prime too. And certainly notationally, what would that be? Well, it would be f double prime now. Now here comes the tough part. Someone says, could you keep doing with that, the Leibniz notation? You can, but now it's going to look a little strange to you, but it's safe to have familiar to it. What we do is we say, we took it twice, and it's written down this way over here like this. All right, let's keep going. Now, of course, if you did it once and then twice, you probably could do it 3 times. What does that mean? I'm going to take the derivative of the second derivative. Well, I'm going to say triple prime now. Well, keeping in the nature of this, what I'm going to write now, the Leibniz notation, d3 dx cubed. All right, it's just notation. It says we're taking it 3 times. Here comes my big issue. And I want to point out, this can go on forever. Once we get to this one, I'll read the 4th one, right? I can't write down these hash marks anymore. So we have a generalized rule that we're going to say that most humans have a tough time counting past 3. So we need to write a numeral down. So I'm going to put down, we do not write this down. It just looks really crazy. Instead, we write down as f parentheses 4. This is to differentiate it between this one over here, which means the 4th power of f. We don't want the 4th power. We want the 4th derivative. We need to do that. So hash marks are only going to go up to 3. Let's review. F prime, y prime, dy dx. F double prime, y double prime, that Leibniz notation. Look where the 2 is. 3rd derivative, 4th derivative. Notice I stopped using primes. So forth and so on. That's what this means until we get to the nth derivative. Someone says, could you do this for a long time? In some cases, it goes on forever. In other cases, it's going to terminate to 0. Now, by the way, some cases it's really easy to differentiate repeatedly. Other cases, it becomes increasingly difficult to differentiate. So what do you need to study from this? Notation. You need to get this notation down as we're writing this down. Whether we're using prime notation or Leibniz notation, you need to get that down. Remember, prime notation, there's prime stuff over here. We are never going to write down more than 3 primes. Then we're going to go to the numerals, and the numeral needs to be written in parentheses. Otherwise, it's a different meaning. All right? Must be written in parentheses. Leibniz notation. Make sure you're aware where those numbers are going. That takes time and effort on your part. Please take the time and effort. What do we do next? We'll do examples of taking the first derivative, second derivative, third derivative, fourth derivative, yada, yada, yada. Thank you.